We like to think we're the peak of engineering. Then you look at what people built thousands of years ago with rope, ramps, and hand tools, and you realize we couldn't rebuild some of it right now even if you handed us the budget. Here are 10 of them. The Great Pyramid. It's around 2560 BC on the Giza Plateau in Egypt, and a workforce is stacking the last of roughly 2.3 million stone blocks into a mountain. When they finish, the Great Pyramid stands about 146 meters tall, and it stays the tallest structure on Earth for the next 3,800 years. Sit with that number. Nothing humans build beats its height until the medieval cathedrals thousands of years later. But height isn't the part that unnerves engineers, it's the precision. The base is leveled to within about 2 centimeters across a footprint that covers more than 5 hectares. The 4 sides are aligned to true north, south, east, and west to within a fraction of a degree, without compasses, without satellites. The blocks average around 2.5 tons each, and some inside weigh up to 80. They're fitted so closely you can't slide a blade between them. We could pour a bigger building today. What we can't easily do is match that accuracy at that scale in stone. Nobody has tried since and succeeded. BAALBEK'S Trilithon. It's the 1st century AD in the Roman town of Baalbek in modern Lebanon, and workers are building a podium for a temple to Jupiter. Into the base they set 3 limestone blocks laid side by side. Each one weighs around 800 tons. That's heavier than a fully loaded jumbo jet times 2. And these aren't lying flat on the ground, they're lifted and placed several meters up, fitted precisely into a wall. Then it gets stranger. In the quarry nearby still lies an abandoned block, cut and ready to move, called the Stone of the Pregnant Woman. It weighs roughly 1,000 tons, and in 2014, archaeologists find an even bigger one underneath it, estimated at around 1,650 tons. The largest stone blocks ever cut by human hands, just sitting there, never delivered. Here's the problem. Almost no crane on Earth today can lift 800 tons, let alone move it, raise it, and set it into a wall with that kind of fit. The Romans do it with ramps, timber, rope, and manpower, and we still argue about exactly how. They cut stones so heavy that modern machinery struggles to match them. 2,000 years ago, by hand. The Pantheon Dome. It's around 126 AD in Rome, and the Emperor Hadrian is finishing a temple with a roof that should not be able to stand up. The Pantheon's dome spans 43.3 meters. And here's the incredible part. It's still, today, the largest unreinforced concrete dome in the world. No steel bars inside it, no hidden supports. Just concrete, holding itself up for nearly 1,900 years. The Romans pull this off with a trick. They vary the concrete mix as the dome rises, using heavy stone at the base and light volcanic pumice near the top, so the structure gets lighter as it climbs. They hollow out coffers in the ceiling to shed even more weight, and at the very center, they leave a 9-meter hole, the oculus, open to the sky. Modern engineers can absolutely build a bigger dome. But to match this one, we use steel reinforcement, which the Romans never had. Build an unreinforced concrete dome this wide today, and it's genuinely difficult, because the knowledge of their exact self-supporting method took centuries to recover. A roof with a hole in the middle outlasts the entire empire that built it. PUNKU. It's somewhere around 550 AD in the highlands of Bolivia, near Lake Titicaca, and a civilization we call Tiwanaku is cutting stone in a way that still doesn't make sense. At the site of PUNKU, the blocks look wrong, not roughly hacked, but cut with flat faces, sharp interior angles, and perfectly straight grooves, as if a machine ran through them. Some are famous H-shaped blocks, identical to each other, like they came off a production line 1,400 years ago. The material makes it worse. Much of it is andesite, a volcanic rock nearly as hard as steel tools can handle. To carve it this cleanly, you need precise, repeatable technique, and the Tiwanaku have no iron, no steel, and leave no writing to explain how they do it. They're 3,800 meters above sea level, in thin air with no wheels and no draft animals strong enough to help, moving stones that run over 100 tons from quarries kilometers away. Modern stonemasons look at those cuts and admit that reproducing them by hand in that rock at that consistency would be brutally hard even now. Then the civilization collapses and takes its method with it. SACSAYHUAMAN. It's the 1400s above the Inca capital of Cusco in Peru, and stonemasons are building a fortress out of boulders that refuse to behave like boulders. The walls of SACSAYHUAMAN are made of enormous limestone blocks, some weighing over 100 tons, a few estimated near 200. And the Inca fit them together without any mortar. None. The stones have irregular, curving faces with dozens of angles each, and they lock into their neighbors so tightly that you can't slide a sheet of paper or a knife blade into the joint. That fit isn't just for looks. It's why the walls survive earthquakes that flatten the Spanish buildings put up centuries later. When the ground shakes, the stones move and settle back into place. Here's what makes it eerie. Every block is a different shape, which means each one is custom carved to match the specific stones around it. There's no standard brick, no repeated unit. It's thousands of unique three-dimensional puzzle pieces, cut with stone and bronze tools, fitted by eye. We build with uniform blocks and mortar because it's faster and easier. Reproducing these mortarless, earthquake-proof, perfectly interlocking walls today would be so slow and costly that essentially nobody does it. DERINKUYU. It's the Cappadocia region of Turkey, centuries ago, and people are digging straight down into soft volcanic rock to build a city where no city should be, underground. DERINKUYU descends around 18 levels, roughly 85 meters, into the earth. Not a cellar, not a bunker, a full city. It has stables, kitchens, wine presses, chapels, schools, and wells. It has ventilation shafts running the entire depth, engineered so precisely that the air stays fresh even at the very bottom, with thousands of people breathing inside. At full capacity, it can hide and sustain up to 20,000 people, plus their animals and food sealed off from the world above. The defense is the clever part. Huge circular stone doors, each weighing hundreds of kilos, roll across the tunnels and lock from the inside, so attackers can't follow. When an invading army comes through Cappadocia, an entire population simply vanishes underground and waits. Try to carve this today and you hit a wall of problems. Structural stability, airflow, water, the sheer labor of excavating a city by hand without collapsing it. We'd need serious engineering to attempt what people here did with picks and patience. An entire town dug downward and it never falls in. Roman concrete aqueducts. It's the 1st century AD across the Roman Empire, and engineers are pouring a material we spent almost 2,000 years failing to fully understand. Roman concrete builds aqueducts that carry water across valleys, harbors that sit in seawater, and structures that are still standing today. Meanwhile, modern concrete built with steel inside it often starts crumbling within 50 to 100 years. The Roman version, sitting in the ocean, gets stronger over time. The secret is the recipe. The Romans mix volcanic ash called pozzolana with lime and seawater, and the chemistry keeps reacting for centuries. In 2023, researchers find another trick. Little white chunks in the concrete, long dismissed as sloppy mixing, are actually a self-healing feature. When a crack forms and water gets in, those lumps react and seal the crack back up. We lost this recipe when Rome fell, and only recently pieced back together how it worked. Their aqueducts move water with gravity alone, dropping a few centimeters per kilometer over distances of 50 or more, so precisely graded that the water flows the entire way. We build faster and cheaper, they built to last. 2 millennia, and did. Petra, it's around the 1st century BC in the desert of southern Jordan, and a people called the Nabateans are building a city by removing rock instead of stacking it. Petra isn't constructed, it's carved. The most famous facade, Al-Khazna, the treasury, is cut directly into a sandstone cliff, around 40 meters tall, with columns and sculptures shaped straight out of the living rock face. And here's the detail that flips your brain. They carve it from the top down. One mistake near the top and you can't undo it because there's no adding stone back. There's no scaffolding and build here, no room for correction. The Nabateans have to plan the entire structure in reverse, cutting away everything that isn't the building. Beyond the facades, they carve a whole city into the canyons, plus an ingenious water system of channels and cisterns that lets a city thrive in the middle of a desert. Carving architecture this precise at this scale directly into a cliff is something we essentially don't do anymore. It's slower and riskier than building, and it demands you get it right the first time. Every time. They sculpted a city out of a mountain and got it right. The Longyu Caves. It's 1992 in Zhejiang Province, China, and villagers are pumping out what they think are bottomless ponds. When the water drops, they find they've been swimming on the roof of something enormous. Beneath the ponds are at least 24 vast man-made caverns, hand-carved out of solid siltstone. Some are dozens of meters deep, with ceilings held up by carved pillars, walls covered in careful, uniform chisel marks arranged in parallel lines like a signature. The scale is staggering. Together, the workers remove nearly 1 million cubic meters of rock. And here is the thing that keeps people up at night. There is no record, no text, no chronicle, no inscription explaining who built the Longyu Caves, when, or why. A project this massive would take enormous organized labor and years of work. And yet Chinese history, which writes down almost everything, says nothing. The caves sit right next to each other, separated by walls sometimes less than 1 meter thick, meaning whoever dug them had precise plans to avoid breaking through. No plans survive. We could carve them today with modern machines. What we can't do is explain how a project this large left zero trace in the records of one of the most literate civilizations on Earth. The Lighthouse of Alexandria. It's around 280 BC on the island of Pharos, off the coast of Egypt, and workers are finishing a tower so tall that ships will see it from dozens of kilometers out to sea. The Lighthouse of Alexandria rises somewhere around 100 meters or more, one of the tallest structures in the ancient world, and one of the 7 wonders. At its top burns a fire, and behind that fire sits a polished mirror or lens that reflects the light far out over the Mediterranean, guiding ships into the busiest harbor of the ancient world. That optical system is the mystery. Ancient accounts claim the mirror can project light for enormous distances, and some even say it can focus sunlight to burn enemy ships. We don't know exactly how it was made, because the knowledge is completely lost. The lighthouse stands for over 1,500 years. Then a series of earthquakes, the worst in 1303 and 1323, shake it apart, and its stones eventually get dragged into a fortress on the same spot. An engineering marvel that guided sailors for 1.5 millennia is gone so thoroughly that we can only guess how it truly worked.